Out of all the prompting tricks that came and went, two survived every model upgrade. Few shot, show, don't tell, and chain of thought, think before answering. And they survived for the same deep reason. Both work by feeding helpful tokens into the context that bias what the model predicts next. You're not begging the model, you're stacking the deck. Start with few shot. Zero shot is when you just describe the task. Few shot is when you also hand it a few worked examples and the model pattern matches and continues the pattern. Say you want natural language times turned into 24-hour format. 3:15 in the afternoon should become 15:15. So you show it 10 to 9 at night, 2050. Noon, 1200. Then you ask 7:30 in the morning and it answers 7:30. Clean. But here's the part people get wrong. You don't cram those examples into one giant prompt. Each example is a separate turn, a user message, then an assistant message, right? There in the conversation. Why does that matter? Because the model treats those assistant turns as authoritative, as proof of how it itself behaves, not as text you pasted as its own track record. And notice the examples are ters, no prose, no markdown, just the answer. The model copies that style exactly. You're not describing the format, you're demonstrating it. When does few shot really shine? Niche formats the model rarely sees. Domain labels like your own P0, P1, P2 matching your brand's tone, and anchoring the weird edge case, which leads to the single highest ROI move in prompting. Your best example is not the most typical input. It's the edge case you keep getting wrong. If the model keeps botching noon as 0000, put noon to 1200 right in the prompt. Mind your eval failures, that's gold. But few shot isn't free. Every example rides along in every single request. More tokens, more cost, more latency. And if you're past 20 examples, you should probably be fine-tuning, not prompting. Now the second survivor, chain of thought. Just ask the model to show its work before the final answer. Watch why it works. A train leaves at 2:15, arrives at 5:03. How long? Rush straight to the answer, and the model often fumbles the non-round numbers. But let it reason. 2:15 to 5:15 would be 3 hours. But we stop at 5:03, so 3 hours minus 12 minutes, 2 hours 48. Correct. The mechanical reason is beautiful. Every token the model generates can look back at every token before it. So by writing out the steps, the model gives its final answer, something to stand on, its own reasoning sitting right there in context. The intermediate tokens are scratch paper, and the model gets to read its own scratch paper. But, and this matters, don't reach for it every time. What's the capital of France? Needs zero reasoning. Caught just burns tokens and adds latency. And the honest warning, chain of thought does not make the model correct. It makes wrong answers sound more confident. It shapes the response. It never adds knowledge. One more fork in the road. Reasoning models, the O-Series, extended thinking Claude, already think internally before you see a word. With those, don't bolt on, think step by step. They already are, and your manual code can actually get in the way. So the rule of thumb, is the task hard for a human? Math, code, multi-step planning? Reach for a reasoning model. Everything else, a standard model with a sharp prompt, is faster and cheaper. Show, don't tell. Think, then answer. Two tools, not magic, but used at the right moment. They're the difference between a model that guesses and one that gets it right.